penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang berasal dari Pulau Mutiara. Pemanis kata selamat datang, awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani dan selamat datang ke Pusat Tuisyen Online Fizik PERCUMA yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama IDD Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Saya Cikgu Hasnitah, presenter anda pada malam ini akan menemani anda dalam tempoh lebih kurang 1 jam untuk satu lagi kelas online percuma bagi Fizik SPM tingkatan 5 iaitu tajuk 1.4 Elasticity. Jadi seperti biasa sebelum kita bermula, ayuh kita buka majlis ilmu kita pada malam ini dengan Ummul Kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan majlis ilmu kita pada malam ini mendapat rahmat dan berkat daripada Allah Subhanahu Wa Taala. Sekali lagi selamat datang kepada semua guru, murid-murid dari seluruh Malaysia di mana jua anda berada. Cikgu doakan anda sentiasa berada dalam keadaan sihat walafiat. Jadi seperti biasa, ini adalah PDF, nota PDF kopi yang cikgu sediakan untuk kelas pada malam ini. Anda boleh lihat pautan dia di skrin sekarang. Anda boleh klik pada pautan ini dan boleh muat turun dan cetak keluar modul ini secara percuma sahaja. Anda juga boleh dapati link ini pada bahagian deskripsi video. Okay, mudah-mudahan bahan yang cikgu sediakan ini membantu anda untuk faham tajuk ini dengan lebih baik insya-Allah. Jadi kalau semua sudah bersedia, ayo kita mulakan kelas pada malam ini. Sebelum itu cikgu tunjukkan dahulu, ini adalah jadual kelas tuisyen online percuma kita bagi subjek fizik untuk minggu ini. Telah disampaikan pada Jumaat yang lepas, tajuk 2.2 graf gerakan linear oleh teacher Slinda Nordin. Siapa yang terlepas siaran langsungnya, jangan risau, anda boleh tonton semula ulangannya di channel teacher Slinda Nordin ataupun di channel Cikgu Rosemawati. Dan pada malam ini, cikgu akan teruskan dengan 1.4 1.4 Elasticity. Ini adalah tajuk yang terakhir untuk fizik tingkatan 5 bab 1. Cuma cikgu nak minta maaf sebab modul cikgu pada malam ini adalah dalam bahasa Inggeris sahaja. Tapi tiada masalah, yang bukan DLP pun boleh follow sebab bahasa yang cikgu gunakan adalah bahasa yang mudah, jadi anda boleh faham tajuk ini walaupun anda bukan di kelas bukan dalam kelas DLP. Okay, ini adalah barisan guru-guru sukarelawan fizik di Akademi Youtuber yang telah banyak membantu saya untuk menerbitkan video-video PDPC sama ada untuk kelas DLP maupun kelas bukan DLP. Di mana nak dapatkan video-video cikgu ni? Anda boleh muat turun apps ini di Android anda hari ini juga kalau belum download lagi. Apa yang kita ada dalam apps Akademi Youtuber ini, setakat hari ini kita ada lebih kurang 28,000 video PDPC yang telah dihasilkan oleh guru-guru sukarelawan AYU dari seluruh negara, seluruh Malaysia, bermula daripada prasekolah hinggalah ke pra-universiti. Jadi video-video ini diharapkan dapat membantu memperbanyakkan lagi sumber rujukan anda selain daripada yang diberikan oleh cikgu anda di sekolah. Okay, so without further ado, students, if you are good and ready to go, Let us begin with our lesson tonight. This is Chapter 1, Force and Motion 2, Content Standard 1.4, Elasticity. So students, in your textbook, this lesson is discussed from page 24 until page 32. Okay, and altogether we have 4 learning standards for you to understand and master them well. So the first one is to describe elasticity. Second, there is an experiment to investigate what is the relationship between force and extension of spring. And the third one is to communicate about the law related to force and extension of spring. Later we will see there's one law called Hooke's law here. And last but not least, the most important one is the solve problem involving force and extension of spring. So ada 4 standard pembelajaran. Yang pertama, apa itu elasticity? Yang kedua, kita ada satu eksperimen yang menghubungkan di antara daya dan juga pemanjangan spring. Dan seterusnya yang ketiga, kita ada satu rumus yang kita boleh kaitkan dengan hubungan di antara daya dan pemanjangan spring yang kita panggil sebagai Hooke's law. Dan akhir sekali, murid-murid kena tahu untuk selesaikan sebarang masalah yang berkaitan dengan daya dan juga pemanjangan spring. Okay, so let us begin with the first learning standard. Okay, this is an idea to describe what is elasticity. Okay, if you look at the short animation, student, what did you see? A diver compete in 3-meter springboard event. So, but I can tell you this is an amateur diver, just a beginner. Ini adalah individu yang baru saja menceburi bidang terjun. Kalau anda tengok gaya dia terjun pun tak berapa betul teknik yang digunakan. But never mind. Okay, so the question is, why does the boat bend when the divers stand on it? So I want you to observe when this diver stand on this boat. So why the boat bend? Kenapa papan anjal bengkok apabila penerjun itu berdiri di atasnya? Apa yang berlaku di sana? So kalau anda tahu jawapannya, boleh respon pada live chat. What causes the springboard to be bent when the divers stand on it? Yes, very good. So this is to do with force. Okay, the weight of the diver is actually a force applied onto that board. So a force is applied to the springboard. Alright. And then second question, what happened to the boat after the diver dive into the swimming pool, student? Apa jadi pada papan anjal selepas penerjun itu terjun ke dalam kolam renang? So you can see that. Yes, look at that. So what happened to the boat? Yes, it returned back to its original position. So we say the boat returned to its original shape or original position. Papan anjal kembali kepada bentuk ataupun kedudukan asal. Okay. Simple. Okay, kita tengok situasi yang kedua. Let us take a look at the second situation to understand what is elasticity refers to. Okay, here you are given 2 springs, spring A and spring B. Can you tell me what happened to spring A and spring B when we applied force onto them? Any difference you can see? Ada beza tak pada spring A dan spring B bila kita kenakan daya ke atasnya? Yeah, very good. You can see when we apply force at the end of spring A, the spring extend. Yeah, spring A dia akan memanjang. While what happened to spring B, when we apply a force onto the spring, yes, the spring compress. Manakala spring B dia dimampatkan. Alright. Okay, so what happened to spring A and spring B? So this is the way we respond. Spring A extended or spring A stretch. Spring A elongate while spring B compressed. Okay, what happened when the force applied on both spring remove? So you can see when we remove, yes, so both spring return to their original position or original length, original shape. Okay, both springs return to their original length or original shape, or you can say original size as well. Alright, okay. So from these 2 examples, student, daripada kedua-dua contoh ini, apa yang kita boleh katakan tentang elasticity, keanjalan spring? Alright, so the springboard and the spring are an elastic material. Okay, so what is elasticity? Elasticity is the property. Okay, it's the property of material that enable an object to return to its original shape and size after the force applied on it is removed. So this is the definition for elasticity, which you can find from your textbook on page 25. Okay, I repeat, what is elasticity? Students, elasticity is the property of material that enable an object to return to its original shape and size after the force applied on it is removed. So the highlighted one is the keyword for the definition of elasticity. Alright? Okay, so you are now clear with elasticity. So let us now take a look at the elastic property of a material. How an object could be elastic. Bagaimana sesuatu objek boleh menjadi objek yang kenyal. Tadi cikgu kata keanjalan, sebenarnya dia kekenyalan. Okay? Bagaimana sesuatu objek boleh bersifat kenyal. How an object can have the elastic property. So this is what happened to a structure of spring in its original shape state. Mean there is no force applied onto the spring. So what happened? No external force applied to the spring, okay, at this situation. So you can see that all the spring molecules are at equilibrium distance. The distance between one molecule to another all are at equilibrium, same distance. So the intermolecular forces are zero. Okay, we have two types of intermolecular forces exist in a elastic material. First is the attractive force. Second is the repulsive force. So in this situation now, since they are in equilibrium position, so the intermolecular forces is zero, which means the attractive force is equal to the repulsive force. All right. And then now students, in the second diagram down here on the left, this is what happened when the spring is stretched. Okay, we apply a force to this end, so the spring will be stretched or extended, okay, to a certain length. And what happened now to these two forces, student? When a spring is stretched, so what happened? The spring molecule displays away or further from one and another. So the molecule, when you stretch them, the molecule become further apart or away from one and another. And at that moment, the attractive intermolecular force will act or will increase. So by that, the spring molecule will be pulled back to the original position. So when you stretch a spring, that is the action. So there will be a reaction from the attractive intermolecular of the force where it will be increases so that it will pull back the spring to its original position. Okay, that happen. Itu yang berlaku apabila kita regangkan sesuatu spring. Kita kenakan daya spring itu memanjang. So apa berlaku sebagai reaksinya, daya tarikan akan meningkat dan akan menarik kembali molekul spring kepada kedudukan asal. Alright. And third, what happened when we compressed a spring? Okay, when we apply a force to this spring, so it will be shortened or compressed. So now at this moment, the spring molecule will displace closer to one and another. Sekarang molekul-molekul spring akan menjadi rapat antara satu sama lain. Okay, so then repulsive intermolecular force will react and increases. This is to push back the spring molecule into its original position. So seperti tadi, yang ini adalah opposite, bertentangan dengan keadaan tadi. So bila kita kenakan daya, spring akan memendek. So molekul-molekul spring menjadi lebih rapat dan pada ketika itu daya tolakan intermolekular akan bertambah dan akan menolak semula molekul spring kepada kedudukan asal. Okay, so this is the elastic property of a material. It is due to the two kind of intermolecular forces exist in an elastic material, named as attractive force and repulsive force. So are you clear so far, student, with the discussion? If you do, can you please give me some response by type number 1 in the live chat? Thank you. All right. Okay, now let us see checkpoint 1.4.1. You are given a few example of material that can you tick. For those who have download and printed out this module, you can do them, okay, on this page. So you just tick on the elastic material. So we have pen, sponge, book, plasticine, scrunchies. We have a elastic rubber band, a stick, and also a rubber band. Kita ada Norma Karim di sana. Waalaikumsalam, Nora Imeh Karim. Nora Imeh Karim. Minta maaf kalau saya tak sebut dengan betul. Adakah, saya rasa ini, adakah cikgu? Cikgu Nora Imeh? Okay, terima kasih kerana ikuti kelas tuition online fizik bersama Akademi Youtuber. Okay, so you just tick on the elastic material. So which are they? Yes, sponge, elastic material, scrunchies, yes, and then we have the rubber band is used for exercises, and also the rubber band which is used to tie our hair. Alright, student. Okay, so done with the first learning standard. What is elasticity? So it is a property of a material where an object will be able to return to its original shape, original length, original size after the force applied to it is removed. Okay, apa itu kekenyalan? Dia adalah sifat pada sesuatu objek ataupun jasad di mana jasad itu boleh kembali ke bentuk asal, ke panjang asal, ke saiz asal apabila daya yang dikenakan ke atas objek dialihkan. Okay, senang saja. Okay, now we go to the second learning standard, student, is to experiment, to conduct an experiment to investigate the relationship between force and extension of spring. So if you look at this diagram in your textbook, this will be on experiment 1.1. All right. Okay, look at this diagram. Diagram 1.4a and 1.4b. It shows a father and his son sitting on two identical bird nest swing. So this is the important information. The two bird nest swing are identical. Identical mean they are made from the same material, they have same size, same dimension, okay, and etc. So the spring of the swing are extended when set by them. Okay, so we can say that actually the weight of the father and his son is represent the force applied on the spring, okay, on this bird nest swing. Okay, so do you remember how to write an inference and hypothesis for an experiment? Bagaimana nak tulis inference dengan hypothesis? Apa format untuk inference dan hypothesis? This will be very useful especially during your UAS later on, ujian amali sains. Okay, so what is inference? So inference we write how does the MV affects the RV. So that is the format. So our MV here is the force. Force affect the extension of a spring. Or you can say the extension of a spring is affected by force. RV is affected by or depend on MV. Okay, the other way around. Either the first statement or the second statement could be your inference. The word is affected here can be also replaced with is depend on. Okay, depend on force. All right. So hypothesis. Hypothesis is an earlier prediction. Now, what will happen in this experiment? Jangkaan awal. So we predict that the greater the force, the greater the extension of the spring. Okay, the greater the force, which is the MV, so the greater the extension of the spring, which is the RV. Okay. Okay, then the aim. Okay, next aim. Okay, aim is the format for aim is to to study or to investigate. That is the format. To study or to investigate the relationship between MV and RV. So here, to study or to investigate the relationship between force and extension of spring. Okay, our MV is the force, extension of spring is our RV. So then we write all the variables related to this experiment according to the information and arrangement of apparatus here. So our MV is the force, so we give a symbol represent the force F. Responding variable is the extension of a spring. Again, we give a symbol to it, which is X. And our fixed variable is the spring constant. Okay, spring constant is a number, is a value which determine the elasticity or the stiffness of a spring, student. And spring constant is depend on 4 factor. Diameter of spring coil, you can write a length of spring, you can write thickness of spring or material of spring. So all these parameter or quantity represent the spring constant. So it must be keep constant or fixed during this experiment. Mean you must use the same spring when conducting this experiment. And this is all the list of apparatus and material required for this experiment. All right. And you can see this is how we arrange the apparatus and material related to this experiment. Okay, next. So the procedure you may read. Okay, you may read from number 1 until number 4. So how to write a procedure, student, for unguided experiment. Okay, remember the step for procedure, you always started with this format. First, how you control the manipulated variable. Okay. Second, how you control or how you read the responding variable. And third is the repetition with a different value of manipulated variable. Normally, we repeat with 4 different value of MV. So here, the first one, original position of the pin, original length is determined. Okay. Second, a slotted weight of 50 grams. So we start with the mass of 50 grams is hung at the end of the spring. The reading of the new position is taken. Okay. Then the extension of the spring is measured. Measured using what? You must add here with the instrument you are using. Extension of the spring is measured using a meter rule, for example. And it is determined from this equation. And finally, the repetition. Experiment is repeated with mass of 100 gram, 150, 200 and 250 gram. Okay. And then we tabulate our result in a table like this. For each column, you must have the quantity and the unit for each. Don't forget quantity and unit. So first is the mass, second is the force or the weight, and then this is the new length, final length after each additional of mass, and finally our extension. Okay. So students, let's say this is the example of data analysis we determine from the table. So we plot a graph of F against X. Okay, so you just plot each point according to the reading in the table. So for this experiment, an F against X graph will be a straight line graph passing through the origin. All right, okay. So how to find the gradient, student? Okay, how to find the gradient? So the gradient is determined from any 2 points along the line. So you can take any 2 points along this line. So I mark my first point here, and this is my second point. Okay, where it is easy for me to read the graph. So remember the gradient formula, y2 minus y1 divide x2 minus x1. So this is my first point, 0, 0. And this is my second point, 0.03 and 3 in the y-axis. So y2 minus y1 divide x2 minus x1. So it will give me 100 Newton per meter. Okay, 100 Newton per meter. So this is the unit in the y-axis, Newton, and this is the unit in the x-axis, meter. So y per n is Newton per meter. Simple. Okay, and then second, find the area under the graph when the extension is 3 cm. So this is where the extension is 3 cm. In this graph, the unit is in meter. So we find the area of this shaded region. So it has a triangle shape, which means you have to use the formula for area for triangle. Easy. Okay. So if you calculate, this is our triangle, half multiplied by height multiply base. Okay, so the height is 3 Newton and the base of this x is 0.03 in meter. So the answer is 0.045 Newton meter, which is also equivalent to 0.045 joule. Okay, 1 Newton meter equivalent to 1 joule. Alright, so later we will see what is the quantity represented by the gradient of the graph and what is the quantity represented by the area under the graph. Okay, so how we discuss? And now we do discussion on our data analysis. Okay, first from the graph, what is the relationship between f and x, students? If you know the answer, you may type them in the live chat. Okay. Apa hubungan di antara f dengan x? Okay. Anyone? You can try. Okay, you can try to share the answer here. Alright, and for those who would like to join me in the studio this evening, you can click on this link to be invited in the studio. So I will invite you so you can be in YouTube as me. Okay, siapa nak join konti cikgu boleh klik pada link ini menjadi tetamu cikgu di studio pada malam ini. Nanti di hujung kita ada satu slot untuk ucapan Salam Ramadan dan juga ucapan untuk Selamat Tahun Baru Cina. So mungkin anda dah ucapkan kepada rakan-rakan ataupun ahli keluarga, boleh ambil kesempatan ini di hujung kelas ini nanti. Okay, so we go back to the question. So the relationship from this graph, again it is a straight line graph passing through the origin. So we know the relationship. F is directly proportional to the extension of spring. F berkadar terus dengan pemanjangan daya berkadar terus dengan pemanjangan spring. Alright, and then student, okay, this is what we determined earlier. What is the gradient of the graph represent? Actually, the gradient of the graph represent the spring constant. Okay, nilai kecerunan graf mewakili nilai pemalar spring. Okay, unit dia Newton per meter. So in this case, it is 100 Newton per meter. Okay, what about the area under the graph? What does it represent? It is actually represent the elastic potential energy stored in the spring when the spring is compressed or stretched. Okay, so luas di bawah graf menunjukkan tenaga keupayaan elastik apabila spring diregangkan ataupun dimampatkan. Unit dia Newton meter ataupun joule. Alright, easy. Okay, now if you understand all the discussion until this point, let us try to respond to this question. Okay, checkpoint 1.4.2. Okay, cuba jawab bersama-sama cikgu. Okay, you are given this diagram. It shows the graph of force against extension of spring X. Graph of F against X. And this is a straight line graph from the origin, so we understand F is directly proportional to X. Alright? Okay, and there is a shaded region show there when X is at 6 centimeter, the extension. So the question is, what is the elastic potential energy stored in the spring when it is stretched for 6 centimeter? Remember from the previous slide, how to determine elastic potential energy? Yes, we must find the area under the graph, the area of the shaded region. And student, since the unit for elastic potential energy is joule, where joule is equivalent to Newton meter, so each mean the extension must be, when you calculate, it must be convert into meter. So this 6 cm must be converted into meter, which is 0.06. So what is the formula for this area? Yeah, so elastic potential energy equal to the area of triangle. So half multiplied by height multiplied by base. See, the base here is in meter. Okay, so answer is 0.18 Newton meter equal to 0.18 joule. So which one is the answer? Clearly it is A, 0.18 joule. Easy, right? Senang sahaja. Okay, so done with our second learning standard. Okay, to conduct an experiment to understand or to study the relationship between F and X. So from the experiment I show you just now we understand F is directly proportional to X. Force applied to a spring is directly proportional to the extension of spring. Alright. Okay, now let us move to the third learning standard. Okay. To communicate about the law related to force and extension. So I mentioned the law earlier in this lesson. It is called as Hooke's law, student. Hooke's law. Hooke apostrophe S. Hooke's law. Okay, so from your textbook, page 27, what is stated in Hooke's law? Apa yang tertulis dalam hukum Hooke? Hooke's law say that the extension of a spring is directly proportional to the force applied on the spring, provided that the elastic limit of the spring is not exceeded. So this is what we did earlier in second learning standard. Hooke's law katakan pemanjangan spring adalah berkadar terus dengan daya yang dikenakan ke atas spring bila mana had kenyal spring itu tidak melebihi ke had kenyal spring. Apabila daya yang dikenakan tidak melebihi had kenyal spring. Okay, and this is the formula for Hooke's law. F equal Kx. F is the force applied on the spring, unit Newton. K is the spring constant. Okay, spring constant. Newton per meter is the SI unit. And X is the extension of spring. The SI unit is in meter. Okay. So student, what is elastic limit mentioned in the Hooke's law just now? Apa itu had kenyal? Okay, elastic limit refers to the maximum force that can be applied to a spring such that the spring will be able to restore or to return to its original length after the force is removed. So had kenyal adalah daya maksimum yang boleh dikenakan ke atas spring di mana spring boleh kembali kepada panjang asal apabila daya dialihkan. So what happened to the spring if you apply a force which is greater than the maximum force it can hold or it can withstand? So at that moment we say the spring will be deformed. Spring itu akan hilang had kenyal dia. It will lose its elasticity and cannot return back to its original shape and size. Okay, kita ada rakan di studio, nanti di hujung nanti cikgu jemput dia naik pentas. Alright, okay. Okay, so this is the graph I show you just now, graph of F against X. So what is the information we can determine from this graph, student? Apa maklumat yang anda boleh dapat daripada graph ini? So you can see there are a few points there, O, A and B. Okay, so point OA, this is a part where the spring obeys Hooke's law. Okay, where F directly proportional to X. Okay, and what happened at point AB? So if you see point AB is a curved line, it is no longer a straight line. So at this region AB, we say the graph does not obey Hooke's law anymore, which means the elastic limit of the spring has been exceeded. Daripada point A kepada point B ni, had kenyal spring telah daya yang dikenakan telah melebihi had kenyal spring. So kita kata dekat point ini spring itu tidak lagi mematuhi hukum Hooke. Okay, so F equal to Kx is not applicable anymore along this line AB. Okay, and again the area under the graph represent the elastic potential energy of the spring. Okay, what is elastic potential energy? How much work is done to stretch or to compress a spring for each 1 meter. Itu maksud dia. Alright, okay, next student. Again, okay, the gradient of the graph represent the spring constant. Kecerunan graf mewakili pemalar spring K. Okay, pemalar spring K. Okey, nampaknya rakan kita telah bersedia untuk kita naikkan. So, cikgu akan naikkan Encik Ayau ke studio. Hello, Cik Ayau.
Halo,
Sihat
sehat.
Okey, mana baju merah Cik Ayau? Tak pakai baju merah, ang-ang. Okey, tak mengapa. Nanti kita ucap selamat tahun baru Cina dekat hujung nanti Okey, kita sambung dulu pembelajaran kita.
Cikgu Hasnitah,
Ya.
nak duit ampau dah hingga main je.
Nanti dekat hujung. Okay? Okay, right. Okay. Then students, okay, so this is all the information you can get. So unit, SI unit for spring constant is Newton per meter. But it can also written in Newton per centimeter or Newton per millimeter. Okay. So what is actually the force constant refers to? The force constant of a spring actually represent the stiffness of the spring or how hard the spring is. If the value of the spring constant is higher, it tells us that the spring is more stiff or it is a hard spring. If the value for the spring constant is small or low, so it tells us the spring is less stiff or it is a soft spring. Kalau nilai K itu besar, maksudnya spring itu adalah spring yang keras. Okay, spring yang keras, more stiff. Kalau nilai K itu kecil, maksudnya spring itu adalah yang spring yang lembut. Okay, lembut. Okay, so now what is the factor affect spring constant? Tadi cikgu ada bagi tahu ada 4 faktor yang mempengaruhi kekenyalan sesuatu spring. Okay, there are 4 factors affect the value of the spring constant or affect the stiffness of a spring. So the first one is a type of material, jenis bahan spring. Contoh di sini kita ada steel spring and copper spring. Steel keluli, spring keluli dan spring kuprum. Dua jenis spring yang berbeza. So definitely the K will be different for spring constant. Second factor is the thickness of the spring wire, student. Ketebalan spring. Okay, ketebalan dawai spring. Nampak sebelah kiri ini spring lebih tebal. Okay, this spring is thicker and on the right it is thinner, lebih nipis. Okay, the third factor is the diameter of the spring. Okay, diameter of the spring. So this is the diameter of the spring. Ini diameter spring. So on the left is larger diameter, on the right is less diameter. Okay, the third factor is diameter. And then the fourth factor, length of spring. Faktor keempat, panjang spring. Okay, nampak sini, on the left this is a short spring, on the right it is a long spring. Ada 4 faktor. Jenis spring, ketebalan dawai spring, diameter spring, dan juga panjang spring. Alright. Type of material, thickness of spring wire, diameter of spring, and also length of spring. Okay, kita tengok contoh di sini. Okay, example, we have 2 spring here according to this diagram, students. Spring A and spring B of same length. Nampak? Okay, 3 faktor dia sama. Panjang dia sama. Okay, ketebalan dawai spring sama, diameter spring pun sama. Yang tak sama adalah jenis spring. Okay. Okay, so apa jadi pada sini? Both spring are stretched by hand. Kita letak beban di bawah sini. We place a load here with a mass of 50 gram. So you will see both spring will be stretched. Kedua-dua spring akan memanjang. Okay, Cik Ayau, boleh respon kepada cikgu tak? Apa jadi pada spring A dan spring B kalau kita letak sesuatu objek di bawah ni? Apa jadi pada spring? Spring itu memanjang ke atau dia memendek?
Memanjang. Memanjang.
Bagus. Ya, bagus. Betul. Spring akan memanjang. The spring will be extended when we apply a force to it. Okay. So we continue with this experiment by repeating with pair 2, pair 3 and pair 4. Okay. This is the first pair tadi. The first pair, they are different in type of material. Another 3 factor is constant. So you can see steel spring will extend by 1.5 cm. Copper spring extend by 2.4 cm. Ciaya, tengok jadual cikgu. Ini antara spring
Okay.
steel dan copper, siapa yang pemanjangan dia lebih tinggi? Copper atau steel? 1.5, 2.4. Copper, maknanya copper itu dia jadi pemanjangan dia adalah lebih. So, boleh bagi tahu cikgu spring mana yang lebih keras? Spring mana yang lebih lembut? Steel lebih keras ke atau
Biru.
lebih lembut? So kita nampak, yes. Okay. So, when the extension of copper is greater, so we understand copper has a lower spring constant because it is a less stiff spring. And if you look at the second pair, now the factor is the diameter of the wire, mean the thickness. Okay, the thickness of the wire. And you can see a spring with the high thickness extend 1.1 cm, but the spring with a small thickness or thinner spring extend to 1.6. So here we understand when the spring is thicker, it has higher force constant. And the third factor, we adjust the diameter. Okay, we study the diameter of the spring. So one spring with large diameter, one spring with small diameter. And the result show that a spring with diameter extended to 1.3 cm, while a spring with small diameter extend to 0.8, showing that small diameter spring has a higher force constant. Okay, and the fourth factor, we study the length of the spring, short spring and long spring. So from this result, long spring extend more 1.8 compared to short spring extend to 1.2 cm. So we understand long spring has a lower force constant. So if you look, student, from this reading, the value of x is inversely proportional to k. Okay, so when k higher, x will be lower or vice versa. When x higher, the value of k will be lower. Alright, so we can say that when the k is high, so it shows the spring is more stiff. When the value of k is low, so it shows the spring is a soft spring or a less stiff spring. Okay, so later we will conclude. Okay, there will be a short abbreviation how to memorize these 4 factors which affect the spring constant of a spring. Alright, okay, now we try this question. 1.4.3. Okay, you are given 2 spring there, R and S. Okay, this is a graph of F against X for 2 spring. This is the graph for spring R and this is the graph for spring S. And you are given this question. Okay, which statement about spring R and S is correct? Pernyataan mana yang betul antara spring R dengan spring S? Okay, daripada graph ini, okay, from this graph we understand R has a higher gradient. Okay, spring R has a higher gradient, which means spring R has a higher force constant. We understand spring R is more stiff compared to spring S. Okay, so which one is the correct answer? Okay, so you can read all the option first for A, B, C, and D. Okay, which one is correct? This is a footnote I give you to help you to determine which one is the correct answer. So just now from the table, student, when K is high, we understand the spring has a large diameter of weight, or the spring is thicker. Okay, and it has a small diameter and the length is short. Okay, thick spring, small diameter, and short spring has a high force constant. Okay, so you can use this abbreviation T. Okay, T for thick. Okay, thick spring. S for small diameter, and then S for short spring. So we can use this abbreviation SST. SST give you high K. What is SST? It's not a sales and service tax, but it is a short, small diameter, and thick spring. Okay, give you high K. SST. Short spring, small diameter spring, thicker spring, give you higher force constant or higher spring constant, means the spring is more stiff. So the correct answer is S. Spring S has a smaller stiffness compared to spring R. A, B, and C, A, D all are wrong answer. Okay, very good. Okay, what if we take a short break before we come back to the final learning standard where we will solve a few questions involving force and extension. Jangan ke mana-mana, kita berhenti rehat seketika. Selepas ini kita kembali dengan standard pembelajaran yang keempat untuk kita selesaikan masalah yang berkaitan dengan daya dan pemanjangan spring. Okey, jumpa anda selepas ini. Okay, kita kembali lagi. Welcome back to our physics online classes. I'm Cikgu Hasnitah from SMK Bagan Jaya Butterworth, Pulau Pinang, your presenter for tonight. You are now watching free online tuition for Physics SPM for Form 5 with content standard 1.4 Elasticity. Okay, Ciayau, kita dah sampai ke bahagian terakhir. Kita cuba selesaikan beberapa masalah berkaitan daya dan pemanjangan spring. Okay. Okay, students. Okay, first and foremost, this slide shows you the arrangement of spring. Ini ada dua cara bagaimana kita boleh susun spring dalam satu sistem. Okay, the first arrangement is called a series arrangement. Susunan sesiri. Susunan sesiri means spring itu disambungkan antara satu sama lain. Okay, series arrangement. So these two spring are arranged in series, one after another. Okay, seperti rantai, sambungan rantai, one after another. Okay, second we have parallel arrangement. Ini kita panggil sambungan selari. Okay, selari mean both spring are put one after another. Spring diletak bersebelahan. Itu sesiri, yang ini selari. Series and parallel. Okay, for each arrangement, they will give you different F, different X on each spring. Okay, kita letak beban di sini. We apply force down here in this series arrangement. We also apply a force down here in the parallel arrangement. Okay, students, so what will happen in series arrangement? The stretching force will act on each spring. So the first spring will experience F Newton. The second spring also experience F Newton. Alright, if F is 10, which means the first spring experienced 10 Newton. The second spring also experienced 10 Newton. Okay. For parallel arrangement, when you apply force F here, so what happened? This force will be divided equally into each spring. So F divided into 2 since we have 2 spring here. If we have 10 spring arranged in parallel, so F will be divided to 10. Alright. So the tension here, F divided 2. So the first spring, the full whole F divide 2 Newton. Second spring also whole F divide 2 Newton. Okay, now the extension. What happened to the extension? So when we apply F, so the first spring will extend, so do the second spring. And the extension for the first spring, it will be X. Second spring also will be X. So the total extension is x plus x, 2x. If we have 5 spring, so it will be x plus x plus x plus x plus x will be 5x's. Okay. While for parallel arrangement, what happened to the extension? Okay, the extension of the system of the spring will be divide by the number of spring in the system. So for here, since they are in parallel, so the extension is x divide 2. If we have 5, so it will be x divide 5. If we have 10 spring arranged in parallel, so the extension will be x divide 10. Okay, are you clear with that? Easy. Okay, good. Okay, now students. Okay, now let us take a look at this example. Okay, you are given 3 spring system. The first system, PQ. Second system, we have RX. Third system, we have 4 spring, TUV and W. Okay, Cik Ayah boleh bagi tahu cikgu, sistem yang pertama PQ ini sambungan sesiri atau selari? Series or parallel arrangement, PNQ.
Selari.
PNQ. Series or arrangement, series or parallel? Sesiri. Series. Okay, and this is series. What about RNS?
Siri.
RNS is, ini selari. This is parallel. RS is selari. Parallel. Yes, okay, good. What about this? TUV. So TUV is selari. Okay, TUV is in parallel. Yes, and they are series with W. So for each system, we place a load of 12 Newton at the end. Kita gantung sini 12 Newton, sini pun 12 Newton, sini pun 12 Newton. And you are given with this information, student. Okay. Diagram show 3 arrangement of identical spring, 50 mm length each. So setiap spring ni panjang asal dia 50 mm. Okay. Dan dia punya pemalar spring constant 2 Newton per millimeter, 2 Newton per millimeter. Semua spring adalah identical mean. They have same length, same thickness, same diameter and same type of material. That is meant by identical spring. Okay, so for each arrangement, you have to find the tension in each spring, the extension of each spring, total extension and total length. Okay, so let us try them together. Actually, you can find these exercises in your textbook, page 31 and 32. Okay, kita lengkapkan jadual bersama-sama. Okay, so students, for each spring, so first you have to find the tension. Tension mean the force apply. Okay, sini 12 Newton. Berapa dekat P? Cik Ayau. Berapa Newton dekat P? Berapa? 12 Newton. Yes. Q pun 12 Newton. Okay. Bagaimana pula dengan RNS? 12 Newton ni bagi 2. So R berapa?
12
S
Newton.
Bagus. Ini bagi 2. So R 6 Newton. S also 6 Newton. 6 Newton as well. Okay. Then kita kelengkapkan. Okay. We complete this table. So the tension or the force applied to the spring in P is 12 Newton, Q also 12 Newton. For R and S, they are in parallel, so 6 Newton for each. Okay, for T, U and V, they are parallel, so 12 Newton divide 3, 4 Newton each. T 4 Newton, U 4 Newton, V also 4 Newton. And W is in series, so W will hold 12 Newton. So tension, settle the force. Second, extension. The extension for each. Extension we can calculate from this formula. Okay, from Hooke's law formula. So X is F divide K. So you use the value for each F divided by K. K is given 2 Newton per millimeter. So this one 12 divide 2 is 6. This one also 12 divide 2 is 6. For R, 6 divide 2 is 3. For S, 6 divide 2 is 3. And for T, 4 divide 2 is 2. U also 4 divide 2 is 2. V also 4 divide 2 is 2. Okay. And for W, 12 divide 2 is 6. So settle the extension for each. Okay. Now the total extension of the spring system. So in arrangement A, we have 2 spring in series. So the extension for each is 6. So total is 12. Okay, while for R and S, since they are in parallel, okay, so the total extension is 3 millimeter. And for arrangement C, combination of parallel and series. Okay, so this is the total extension. 2 for T and V and 6 for W. So total is 8 millimeter. Okay, and finally, the total length of the spring system. So remember just now the initial length of each spring is 50. So for arrangement A, 50 here plus 50 here plus 12, the total extension. So the total length of the spring system is 112 millimeter. Okay, while for arrangement B, the initial length here is 50 mm, and then the total extension is 3. So the total length of the spring system is 53 Newton. Okay, while for the third arrangement C, up here initially is 50, down here is 50, and the arrangement total extension of the spring system is 8. So the total length of the spring system is 108 millimeter. Settle. Okay, easy. So if you cannot understand this, you can spend more time to look at them, to analyze them one by one. I believe you will get them soon. Okay, good. Okay, we go to this question, student. Okay, done with the first activity. Now we go to checkpoint 1.4.4. Again, we have 3 systems, P, Q, and R. All spring are identical. Okay, P kita ada 1 spring saja. Q, we have 2 spring. Okay, this one series or parallel? Xiayao, Q. Series or parallel? Sesiri ke selari? Q. Q is sesiri. Yes, bagus. And R is parallel. R ini dia selari, parallel. So for each system, we hang a load of 1 kg, student, 1 kg. Okay, which comparison is correct about the extension of P, Q, and R? Okay, to know that, first you must write the extension. So P will extend by this.
Jawapannya boy.
Boy. Kita tengok dulu jawapan. Okay. Betul ke boy? Okay, nanti kita check. Okay,
Masih,
P
cuba saja.
extension dia X. Q berapa extension dia? Up here is X. Down here is also X. So X plus F, we have 2X. So for Q, we have 2X. Okay, P we have X. Q we have 2X. Okay, what about R? R, this is the extension. It is X divide 2. Okay. So sekarang kita susun nombor. Kita ada X, kita ada 2X, kita ada X bahagi 2. Nilai mana yang paling besar? Which value is the biggest? X, 2X or X divide 2? Nilai mana paling besar? Cayau. Ini X, ini 2X, ini X bahagi 2.
S berdua. S berdua.
So paling kecil is X per 2, paling kecil. Okay. Second adalah X. Yang paling besar 2X. Okay. So by this, X bagi 2 ini R. R less than P less than Q. Okay, boleh bagi tak cikgu Ciaya mana jawapan dia yang sama dengan ini? Which one is the best answer? A, B, C or D?
D.
Bagus. Betul. Jawapan dia D. So the answer is D, donkey. Okay, R less than P less than Q. Okay, good. Okay, next. Tengok pula soalan ini. Yang ini kita kena kira. Okay, we need a calculator for this question. Okay, again we have diagram 1. It shows an initial length of the spring before a force is applied to it is 12 centimeter. And after we apply a force, a load of 300 gram at this end, the spring extend to 20 cm. This is the new length of the spring from 12 to 20 cm. So we understand the extension is 8 centimeter. 20 minus 12, 8 centimeter. Okay, the question asks you to calculate the spring constant. Second, to find the length of the spring when the mass increased to 500. And third, to find the mass of the load required to extend the spring to 30 cm, mean from 12 to 30 cm. How much load is required to be placed there? Kita jawab satu-satu. Okay, so for A, how to find the spring constant? Use Hooke's law. Guna formula hukum Hooke. F equal Kx. Okay. So this F is mg. Mass. Mass must be in kg. 300 grams. So in kg, 0.3 kg. This is gravity. So extension must be in meter. Meter, because the answer must be in Newton per meter. Okay, so the extension is 8 cm, in meter 0.08. So you just do a mathematical operation. So to find K is this value divide 0.08. So answer 36.7875 Newton per meter. Settled. Okay, tengok soalan B. Cari panjang spring apabila jisim beban meningkat kepada 500. So now we place 500 gram here. What will be the new length of the spring? Okay, or the final length of the spring. So this is the solution also. Again, Hooke's law, F equal to Kx. Now the mass is 0.5 kg, 500 gram. Okay, extension. Okay, we want to find the extension. This is the force constant we calculated earlier. So by this, the extension is 0.133 meter. So the final length, 0.133 meter. We plus with the initial length of the spring. It is 12 centimeter. So this one in centimeter. So 25.33 cm will be the final length. Okay. And C, find the mass when the spring finally extended to 30 cm. So finally here we have 30 cm, the final length, which means the extension is 30 minus 12 is 18 centimeter. So this is the extension, 18 centimeter, 0.18 meter. Okay, so now we want to find the mass applied. So again, you substitute the value. So the load here is 0.675 kg or in gram, 675 gram. Okay. Okay, good. Okay, now next question, student. Okay, ini pun sama juga. Sekarang kita compress. Kita letak objek di atas, so spring akan dimampatkan, compress. This is the initial length. Ini panjang asal spring, 50 cm. Then we place a load of 4 kg, so the spring will be compressed to 28 cm. So what is X? 50 minus 24. So the extension or X is 24 centimeter. Okay, the first question, what is the elastic potential energy stored in the spring? So this is the formula to find elastic potential energy, half Fx. Okay, half Fx. So F is 4 times 9.81. Okay, mg. Multiply extension, 24 cm. In meter, 0.24 meter. Okay, so answer 4.7088 joule. Okay, the energy stored in the spring. Finally, if the spring is released, so the load of 4 kg will thrown up. Bila kita lepaskan 4 kg ni, dia akan melambung ke atas. Soalan dia, berapa tinggi maksimum yang dicapai oleh beban? Find the maximum height reached by the load. So what happened when we release? The elastic potential of the energy stored in the spring will be equal to the gravitational potential energy of the load. So EP, elastic potential energy of the spring, equal to the gravitational potential energy of the object of the load. So this value we calculated earlier. So mgh 4 kg This is gravity. So now we can find the maximum height it will reach. So this is the answer, 0.12 meters. So finally, 4 kg will be moved up at the distance of 0.12 meter. Okay, senang saja kan? Okay, now we try to do one essay question. Okay, application, essay question, student. Okay, here we have diagram 2. Pernah main ini tak? Pogo stick. Ciayau, pernah cuba tak? It's a device, pogo stick is a device for jumping off the ground in a standing position to the aid of an elastic spring. So down here, we have elastic spring connected to the pogo stick. Okay, so David weight causes the elastic spring to be compressed. Okay, first, what type of energy stored in the compressed spring? Apa jenis tenaga yang tersimpan dalam spring termampat? Dari tadi cikgu sebut. Apa nama tenaga dia? Tenaga keupayaan kenyal, elastic potential energy. Okay, elastic potential energy. Second, okay, how to respond to this question? Explain why the spring is elastic. By a certain extent, the spring cannot return to its original length when the force is removed. Actually, so this one we have to elaborate or describe the elastic property of material. Okay, so first we write there are two forces between a molecule in the spring, which is repulsive force and attractive force. Okay, so when the spring is compressed, what happened? Repulsive force increases and return the spring back to its original state. When the spring is stretched, so what happened? Attractive force increases and pull. Okay, pull the string back to its original state. So these 2 points, actually we describe the elastic property of material. And then finally, when the spring is applied with the force exceeded with the elastic limit, it cannot return back to its original length. So spring cannot return to its original length if the elastic limit has been exceeded. So we explain the second terms here. Okay, that's all with 4 marks of explanation why a spring is elastic, and at a certain point it will lose its elasticity. Okay, the final question for tonight, student, for this evening. Essay with a 10 marks essay question. Okay, application. Diagram 2.1 shows a weighing machine used in a factory to measure weight of raw material in ton. 1 ton equal to 1000 kg. So a spring is placed under the pan to return the pan to original position when the load is removed. Okay, so down here we have a spring to support the load placed in this weighing machine. Okay, you are given a table of 4 choices, spring P, Q, R, and S with 4 characteristics: weight, force constant, rate of rusting, and type of weighing machine. So for each, we have choices. Okay, so as usual, you can use tick to pick method. So we tick first. The weight of the spring must be high or must be low. The force constant must be high or must be low. The rate of rusting, high or low. Okay, wrong spelling there. For Q, it's supposed to be LOW, low. And the type of machine, weighing machine, extension or compression down here. So we tick. And this is the recommended answer for the weight of the spring. It must be small or it must be low. For what reason? So that it will be light. Okay, it will be light or does not add much to the total weight of the weighing machine. So just write there light. Okay, force constant definitely should be high. Yes, why must be high? So to support more load or to support more weight, or it has a high elasticity. Okay, rate of rusting, high or low, student? Yes, it must be low rate of rusting so that the spring will not rust. The spring will not oxidize. Okay, and the type of weighing machine, obviously it should be compression type. Why? So that it will return the pan to original position after the load is removed. Okay, so compression type. So which one is a better choice? From here we choose Q. Why? Because it has small weight, high force constant, a low rate of rusting, and compression type of weighing machine. Okay, so we have completed our essay question. Okay, last exercises. Okay, for Form 5 student, I believe you for those who have studied this content standard, maybe you have done this as your exercises or your homework. So this is the discussion for formative practice 1.4 in your textbook. Okay, first, what is meant by elasticity? Okay, it is a property of a material where an object able to return to its original shape and size when the force applied on it is removed. Okay, definition. Okay, then second. Okay, second question as we did before. State Hooke's law. So this is Hooke's law. It said that the extension of a spring directly proportional to the force applied on the spring provided the elastic limit of the spring is not exceeded. Okay. Third, find the spring constant from this graph. Okay, how to find spring constant? Yes, from the gradient of the graph. Kira kecerunan graph. Okay, macam mana kecerunan graph? Okay, second sebelum tu B cikgu lupa. Does the spring obey Hooke's law? Yes, the string obey Hooke's law because the graph is a straight line graph passing through the origin. Okay, that's how we explain. Okay, ini macam mana nak kira kecerunan? So the gradient is 15 Newton here. Okay, divide 0.06. Okay, so 250 Newton per meter is the spring constant. And the elastic potential energy, how to find? By calculating the area when the spring extend to 0.4. So we calculate this area only when the extension is 0.04. So answer 0.2 joule. So this is the elastic potential energy stored in the spring when it is extended to 0.04 meter. Okay, and the extension is 0.04 meter. Okay, third question. Okay, soalan ketiga. We have a combination arrangement here of string P, Q and R. Q and R are arranged in parallel and then they are series with P. Then we apply force 8 Newton on top. So each spring experience how much force? So we understand earlier 8 for P, 4 for Q and 4 Newton for R. Easy. Okay, and compression in each spring. So use Hooke's law formula. Okay, so compression is X equal F divide K. So for P, the force is 8. So the spring constant is 4 Newton per cm given here. So the extension is 2 cm. And for Q and R, it will be the same. The extension for each is 1 centimeter. Okay. Okay, then C, find the compression of the spring system. Mean the total compression. So you add all the value for X here. So answer 2 plus 1. 2 for P up here and 1 here for Q and R. So 3 centimeter is the total compression. Okay, last question. Soalan terakhir untuk malam ini. So this graph F against X. What is the force produced extension of 5 cm? So here you are given 5 cm. How to find the value of F here? So what is the formula? Again, F. So we can find the value of the shaded region. Okay, shaded region. So which is represent the elastic potential energy. Okay, because it gives us the value here, 0.4. So 0.4 elastic potential energy equal to half Fx. Okay, so X is given. It must be in meter since this is joule. So by then the force is 16 Newton. Okay, so you need a force of 16 Newton to extend the spring to 5 centimeter or 0.05 meter. Okay, and B, find the spring constant K. Okay, how to find spring constant? Again, using Hooke's law, F equal Kx. So we are looking for K. Okay, F is 16 from the first question. X is 0.05. So by this, the spring constant K is 320 Newton per meter. Okay, so I guess that's all with our discussion tonight. Itu saja perbincangan kita pada malam ini. Alhamdulillah kita dah berjaya habiskan. Okay, Cia Yao, sebelum kita ucapkan selamat tahun baru Cina kepada kawan-kawan kita, cikgu nak bagi tahu dulu. Mulai minggu hadapan kita umat Islam dah bermula puasa. Okey, so kelas kita ada perubahan waktu sedikit. Okey, untuk pemberitahuan kepada semua yang mengikuti kelas fizik online di Akademi Youtuber, sepanjang waktu Ramadan, sepanjang bulan Ramadan, kita ada perubahan waktu siaran. Okey, untuk kelas tingkatan 4 pada Jumaat 39-35, kelas semua ditangguhkan. Maknanya sepanjang bulan Ramadan ni kita tak ada kelas tingkatan 4. Kita tangguhkan dahulu sehingga selepas hari raya nanti. Tapi untuk kelas tingkatan 5 DLP kita akan teruskan seperti biasa pada hari Ahad. Cuma siarannya berubah kepada pukul 11 pagi. Sebab malam kita nak pergi solat tarawih. Jadi kelas kita ubah pada hari Ahad 11 pagi bersama dengan Cikgu Hasnitah, insyaAllah. Itu saja, anda boleh screenshot perubahan ini, boleh simpan supaya anda tidak terlepas kelas Cikgu Hasnitah pada minggu hadapan. Kita akan mula dengan bab 2. We will start with the new chapter, chapter 2, pressure. Okay. Next week will be 2.1, pressure in liquids. Okay. So with me, Cikgu Hasnitah, on Sunday 11 AM. Okay. Itu perubahan siaran sepanjang bulan Ramadan tahun ini. Okay. So itu saja pada cikgu. Cikgu nak persilakan Cia Yao untuk memberikan sedikit ucapan selamat tahun baru Cina. Siapa juga yang nak ucapkan selamat tahun baru Cina boleh klik pada link ini, anda buka kamera, anda boleh buka mikrofon, ucapkan selamat tahun baru Cina kepada sanak saudara ataupun guru-guru anda ataupun rakan-rakan anda di mana jua di seluruh Malaysia. Okey, Cia Yao silakan. Boleh ucap selamat tahun baru Cina. Buka mic Cia Yao. Yeah. Okay, buka mic. Oh ya, yeah, dengar. Okay, good.
Dengar tak?
Ya, yeah. Dengar.
Happy Chinese New Year kepada semua yang beragama Cina. Okey, selamat tahun baru Cina. Terima kasih Cia Yao. Cikgu juga mengambil kesempatan mengucapkan selamat tahun baru Cina kepada semua guru dan anak-anak didik seluruh Malaysia yang merayakan tahun baru Cina, dan kepada yang beragama Islam, selamat menjalani ibadah puasa bermula pada minggu hadapan. InsyaAllah pada hari Khamis kita akan mula berpuasa. Cikgu doakan semoga anda semua sentiasa sihat, sentiasa diberikan kesihatan yang baik, sentiasa gembira bersama keluarga tersayang. Okay, jangan lupa cuti 1 minggu, jaga diri, jaga keselamatan di mana jua anda berada. Cikgu doakan anda sentiasa berada dalam rahmat Allah Subhanahu Wa Taala. Okey, jadi terima kasih Cia Yao kerana bersama-sama dengan Cikgu Hasnitah di studio pada malam ini. Terima kasih juga kepada semua yang telah mengikuti kelas tuition online daripada 8 suku tadi hinggalah sekarang 9.33 malam. InsyaAllah kita jumpa lagi minggu hadapan pada hari Ahad 11 pagi. Ya. Cikgu hantar. Tengok power saya.
Nanti cikgu baca. Okey, kita bye-bye dulu semua. Okey. Segala yang baik itu daripada Allah, segala yang kurang itu daripada kelemahan dan kedangkalan diri saya. Jadi terima kasih kerana bersama-sama dengan kami. InsyaAllah kita jumpa lagi dalam waktu yang akan datang. Assalamualaikum, selamat sejahtera dan bye-bye semua.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi Guru AYU, mencapai misi yang satu. Pervisi kita bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini. Lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa. Bersama kita luar biasa, berjasa demi nusa bangsa. www.akademiyoutuber.com. Berusaha AYU, capai kecemerlangan. Berpadu AYU, cipta kegemilangan. Bersatu AYU, bina wadah terbilang. Terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan. Berpadu AYU, cipta kegemilangan. Bersatu AYU, bina wadah terbilang. Terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan. Tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa. Bersama kita luar biasa, berjasa demi nusa bangsa.